Hi friends, welcome to NetTalks Tamil. Today we are going to discuss about transport layer. What is transport layer? The transport layer is second layer in TCP IP model and fourth layer in OSI model. If you see the OSI reference model, it's a fourth layer. If you see the TCP IP model, it's a second layer. After this layer in TCP IP model, it is application layer. It is an end-to-end layer used to deliver a message to a host. It's termed as an end-to-end layer because it provides a point-to-point connection rather than hub-to-hub between source host to destination host to deliver the services reliably. We already know, okay, the transport layer uses the TCP and UDP protocol. If you want to brief about the TCP UDP, you go through my videos available in my channel. In the data unit of encapsulation in the transport layer is segment. In physical layer, we'll call as a bit by bit. In data link layer, we'll call as a unit as a frame. In network layer, it's a packet. In transport layer, it's a segment. We'll call as a transport layer. The data unit, encapsulate data unit, we'll call it as a segment. How the transport layer working? The transport layer takes a service from application layer and provides services to network layer and vice versa. At a sender side, the transport layer receives a data, which is a message from the application layer. Then it performs the segmentation, divides the actual messages into the segments, and adds the source and destination port numbers into the header of the segment and transfer messages to the network layer. See, when the application layer sends any data, when the transport layer receives the data from application layer, it will do the segmentation. And the segmentation, it will add the source port and destination port. The port numbers and all we will be seeing in upcoming classes. Those source and destination port, it will be added in the segment header. And they transfer the messages to the network layer. And receiver side, when the message receives from the network layer to application transport layer, transport layer reassembles the segment data and reads the header. It will read the header and identify the port number and forward the messages to the appropriate port in the application layer. So whatever the messages receives from the network layer, it will reassembles the segment and reads the header and identify the port number and forward the message to appropriate port in the application layer. Now see the responsibilities of transport layer. The process to process delivery. End-to-end connection between hosts. Multiplexing and demultiplexing. Congestion control. And data integrity and error correction. Final one is flow control. Now let us discuss one by one responsibilities of transport layer. Now the first one, the process to process delivery. See, while data link layer requires the MAC address, we all know MAC address is a 44-bit address which is inside the network interface card for every host machine. Of the source destination, see, based on the MAC address, data link layer, it will deliver a frame to the correct MAC address. Data link layer require a MAC to deliver a correct person. In network layer requires a IP address to deliver a packet to the appropriate person, a host. And then similar way, the transport layer require a port number to correctly deliver the segment of the data to the correct process among the multiple process running in a particular host. If you take a PC, there will be multiple process will be running it. See, for example, if you're taking the mail, it will be using SMTP protocol. And then if you using any SSH connection, it will be using a port 22. If you are doing a web surfing, okay, it will be using a HTTP or HTTPS. Like that, okay, it will be multiple ports and services will be running in the host. It will be identified based on the port. It will be sending to the correct application, appropriate application. See, this port number is a 16-bit address used to identify any client server program uniquely. The port ranges and all, that is a private known port, unknown port and all we will be seeing in upcoming classes. This is the process will be having a multiple packets. Okay, it will be get segmented, and then it will be sending to network layer, and then again it will be demultiplexing, and it will be sending to the process. Now see end-to-end connection between the hosts. The transport layer is responsible for creating an end-to-end connection between hosts, for which it is mainly uses TCP and UDP port. The TCP and UDP port briefly discussed in different video. Please go through that video which is available in our channel. So the TCP is a secure connection oriented protocol which uses the handshake protocol to establish robust connection between two end hosts. And the TCP ensures the reliable delivery of messages, and it's used in various applications like HTTP, HTTPS, SSH, Telnet all uses the TCP connection. Where the other hand the UTP is a stateless connection and unreliable protocol that ensures the best effort delivery. It suits for the application that have little concern with the flow or error control that requires sending the bulk of data like our video conferencing, all those things. Okay, and it often used multicasting protocols. Say the UDP carries a very lightweight. Okay, it's a very lightweight compared to TCP. When we want to send a bulk data like a video conferencing and then voice data, all voice those things and all will be taken care by UDP protocol, where we need to ensure reliable connection. In that scenario we need to use a TCP protocol. We are discussed briefly in TCP UDP in different video which is available in our channel. I'll be putting that video in description as well. Please go through that. Now multiplexing and demultiplexing. See, multiplexing means many to one. When data is acquired from several processes from the sender and it merged into one packet along with the header and sent as a single packet, multiplexing allows the simultaneously use a different processes over the network that running in the host. The processes are differentiated by their port number. Similarly, demultiplexing one to many is required at a receiver side when message is distributed into different processes. The transport receives the segments of a data from network layer and distributes and delivery it's to appropriate process running on the receiver machine. For example, if you're running multiple processes like you're running Yahoo, Gmail, Outlook, YouTube, many things. See, these all the packets. Okay, it will be get multiple packets. Okay, for example, in YouTube you are searching it. Okay, if you are getting multiple traffic, okay, it will be get segmented into many to one, and then it will be sending multiplexing. It will happen, and then it will be sending. Okay, sender will do the demultiplexing, and it will be send it to the application layer. The same way, Google, Yahoo. If you're doing the Yahoo, okay, there is a lot of packets going in Yahoo. Okay, it will be multiplexing many to one, and then it will be sent it to a receiver. Receiver will do the demultiplexing and send it to the application. Similar way for all the application. Okay, but applications, all the applications will not get merged into the one single packet segment. Okay, for a applications are means A application multiple segments will be multiple packets will be getting segmented. If B application multiple packets will be getting segmented one. There will not be any chances to getting multiple packets merging into the single segment. That will not happen here. And then congestion control. The congestion is a situation in which too many sources over a network attempt to send a data and router buffers start overflowing data, due to which loss of packet occurs. A result of transmission of packet from sources increases the congestion further. See, when the packet loss happening, okay, again it will try for the retransmission. Again it will increase the congestion. So the transport layer provides a congestion control in different ways. It uses open loop congestion control to prevent congestion. So it uses open loop congestion control to prevent congestion. Closed loop congestion control to remove a congestion in network once it occurred. The two techniques, one is to prevent, one is to remove congestion. To prevent open loop congestion, to remove congestion in network, it's a closed loop congestion. In TCP, it provides a AIMD. AIMD means additive increases, multi-captive decreases, and leak bucket technique for congestion control. The leak bucket technique, okay, if you receive one packet is bigger, one packet is slower, okay, all it will be burst. It may be something, sometime burst also might happen. So it will be collecting on bucket, and then it will be sending the outflow very constantly. Same way, that is a bucket technique. Constant flow, it will ensure it. Okay, whatever data receives, it will be collected on the bucket. Okay, the bucket will be doing the constant overflow. Now, data integrity and error correction. The transport layer checks the errors in the message coming from the application layer by using the error detection codes and computing checksums. It checks whether the data received is corrupted or not by using the acknowledgement and negative acknowledgement services, ACK and NACK services to inform the sender if the data has arrived or not, and checks the integrity of the data. See, if a sender receives the data, receiver will check it out whether the data is correct. It's the integrity of data and all. It will ensure there will not be any problem with the data. Flow control. The transport layer provides the flow control mechanism between adjacent layer of the TCP model. The TCP also prevents the data loss of due to faster sender and slower receiver. See, for example, the receiver is having a capacity of receiving the 10 MB per second, but sender is having a capacity of 100 MB per second. So both will be using the sliding window protocol method, and then it will be negotiate with one common speed, and it will be sending a data, flowing a data. Here the sender is having a capacity to send 100 MB per second, but receiver is having a capacity to receive 10 MB per second. So it will be only send the 10 Mbps per second by using the sliding window protocol. Thanks for watching NetTalks Tamil. Please like it, share it, subscribe it. If you have any doubts, please drop your doubts in the comment box. It will be addressed in upcoming videos.